Loudspeakers. Loudspeaker comes with a woofer cone that is attached to the magnetic that results in the back and forth movement of the woofer. The magnetic force and the sound waves exert pressure in the air that is felt on the hand if you place your hand near the woofer. The back and forth motion of a woofer moves the air particle according to its motion, thus producing the sound. The motion of the particle is in the direction of the wave traveling out from the woofer, hence it is an example of a longitudinal wave. Tuning forks. On hammering a tuning fork on a rubber pad, it vibrates, giving a sound. This vibrational energy is transmitted in the air and captured by the air molecules. Any vibrating object produces a sound that travels as a longitudinal wave. The tuning fork vibrates, creating the region of high and low air pressure. The prongs of the fork moving inward produces a region of high pressure which is called compression, and as the prongs move outward, a low pressure region is generated which is called rarefaction. Slinky. Slinky is a simple toy that can explain different concepts in physics. It is just an elastic spring. If a slinky is pushed and pulled horizontally, the compression and rarefaction of the coils of a slinky are observed, which appears as a wave. This is a longitudinal wave. The wavelength is the length of the rarefaction, which is a difference between the two compressions of the coils. Microphones. The microphones are used to amplify the sound. When you speak standing in front of a mic, the sound is amplified and travels in the air at different frequencies. The sound waves created from the mouth travel through the air and hit on the microphone that produces sound. A wavelength of a longitudinal wave is a distance between the 2 points where the number of waves is more, that is where the wave is compressed. Acoustic guitar. On plugging a string on guitar, the string vibrates and a transverse wave is generated. The vibrating string produces a resonance effect on traveling the wave from the sound hole. The longitudinal wave is reflected back from the sound hole. Clapping. Clapping hands together to give applaud produces a sound wave. This is similar to the longitudinal wave, where the region of compression and rarefaction of a wave in a fixed time period is formed between each clap. Clapping is compression, and releasing the hands after a clap is a rarefaction. A familiar sound like a wave is generated due to the clapping. Drumming. As we hit a drum with drumsticks, the sound is produced that travels in all directions. The particle even vibrates, that is within the hollow of a drum and outward in the surrounding drum. The vibrations thus produced are transmitted in the air, and the molecules in the air take this vibrational energy, and this energy is transmitted in the direction along with the sound wave. Tsunami. The earthquake that took place on the oceanic floor terms as tsunami, which is a Japanese word. Since the earth erupts into the ocean, the vibrations are produced in the water body, and this energy is transmitted to the shore. The waves initially produced are the transverse waves that are converted into longitudinal waves that travel across the shore. As they reach the shore, the amplitude of the waves becomes shorter and the water moves parallelly to the direction of the wave, hence it is a longitudinal wave. Earthquakes. The vibration felt on the earthquake produces seismic waves. S-wave is a transverse wave that does not travel through the asthenosphere, as the wave propagates in the direction perpendicular to the movement of the molecules. Well, P-waves can travel through any medium, whether solid, liquid, or gaseous, and travel along the direction of motion of the particle and hence travel at a longer distance. These waves are responsible for the movement of the magma back and forth that produces S-waves. Thundering. The thundering of clouds is due to lightning caused by the charged electrons present in the clouds. Due to this phenomenon of thundering during rainy seasons, one important concept came into existence, that is, the light travels faster than sound. The light flashes first and the sound wave of thunder follows the light wave. The wave generated on thundering is a longitudinal wave and travels at a longer distance and reaches the earth. You must have heard the vibrations in window panels on thundering. Lightning causes the formation of shock waves of sound that travels in the form of waves, and the same vibrates the window panels. Sound waves. The sound energy is transmitted to the molecules of the medium, and the wave propagates parallel to the direction of the vibrations of the molecules. The propagation of a sound wave in the medium depends upon the density of the medium, the refractive index of the medium in which the sound travels, and the temperature. The sound waves travel faster in the medium having a greater refractive index as compared to the medium having a less refractive index. Also, the temperature of the medium plays an essential role during the transmission of sound waves. The sound wave travels producing the compression and rarefaction of the wave, which may produce the amount of heat energy, hence constant temperature conditions are required for a sound to travel a longer distance. The condition should be adiabatic. Sonography. Sonography is done to take a picture of the body parts like muscles, bones, body organs, tendons, etc. The ultrasound waves are passed to a respective part of the body by connecting the probes of sonograms. The reflected waves from the organ are processed and are converted into digital images. Sonic weapons. High ultrasound frequencies are injurious to health. Sonic weapons can produce high ultrasonic frequencies and are used by the military and armed forces. The ultrasound is in the range of 700 kHz to 3.6 MHz. These weapons can cause various discomfort in humans, causing disorientation and nausea, can destroy the eardrums, causing several effects. What is longitudinal wave? The longitudinal waves can propagate in all the mediums, whether it is a solid, liquid, or gaseous state. The propagation of the longitudinal waves is in the direction of the vibration of molecules of the medium and hence travels at a longer distance and can even penetrate through the mediums. The longitudinal waves experience a pressure difference due to a creation of a region of compression and rarefaction. The number of waves at the rarefaction of the wave is less compared to the density of the waves at the compression. A wavelength of the longitudinal wave is the distance between the two compression points on the wave. The speed of the longitudinal waves is highest in the solid state as compared to a liquid or gaseous state. Hence, the speed of sound is fastest near the water bodies. How to calculate the speed of the longitudinal wave? We can calculate the speed of the wave using an equation. The speed of the longitudinal wave is the product of its wavelength and the frequency of occurrence of waves. The distance between the 2 points of compression where the density of the waves is more is equal to the wavelength of the longitudinal wave. The frequency of the wave is the number of complete oscillations of the vibrating molecules along the path of the wave in a time period. Characteristics of the longitudinal waves. The longitudinal wave travels along with the vibrating particle on the same axis. Unlike transverse waves, longitudinal waves produce a region of rarefaction and compression. They are also denominated as primary wave or P waves, pressure waves, and compression waves. The longitudinal waves can penetrate through any medium. The speed of longitudinal waves is greatest in solid and lowest in the gaseous medium. The longitudinal wave is the fastest wave as compared to the transverse wave. Even if the speed of the vibrating molecules is changed, the frequency of the longitudinal wave remains the same. The frequency of the waves varies in the region of compression and rarefaction. The distance between two compression points gives the wavelength of the longitudinal wave. Frequently asked questions. Why longitudinal waves are called pressure waves? The longitudinal waves travel through the medium, creating a pressure difference. The pressure developed by the wave is maximum at the region of compression of the wave where the density of the waves is more, and at rarefaction the pressure is low and hence the number density of waves is less. Why longitudinal waves are called primary waves? The waves are produced due to earthquakes and various plate tectonic activities. The seismometers are used to detect the seismic waves. The primary waves are the fastest to travel compared to transverse waves. The longitudinal waves are the first to detect on the seismometers, therefore, they are called the primary waves. Why audio is a longitudinal wave? A longitudinal wave travels parallel in the direction of motion of vibrating molecules. The audio produces the compression and rarefaction of sound waves while traveling in the air, hence it is a longitudinal wave. What is a motion of particles in the longitudinal wave? The particles move parallelly along with the longitudinal wave. The propagating longitudinal wave will move periodically, compressing the wave, forming a region of compression and the rarefaction. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.